Okay, welcome to the improve phase. And where you are now in your kind of process improvement journey is that you would have defined your problem obviously really well. You've mapped it out. You've kind of measured the baseline. You went through the analyze phase, hopefully where you've looked at various different possible root causes. You brainstormed perhaps and did other tasks and things to identify some possible root causes. And then coming out of the analyze phase, before you get here, you would have now had a prioritized list of areas that you want to focus on to fix, right? So possible root causes that you think most impact your problem. So the improve phase is now all about improving that business process. Putting in place, identifying those specific improvements you want to take action on and put in place, and then measure those improvements to see if they've actually had a positive effect, or in some cases no effect. Maybe you didn't quite get it right. Okay, so that's the improve phase. And so a quick overview of what you're going to see. There's two primary outcomes of the improve phase. Okay, so year one going to have a proposed solution, and then you're going to have piloted the solution or implemented that solution. Okay, so that's basically the crux of what you want to do here. Is you're going to go through these kind of three steps where you're going to prioritize and select those improvements based on what you identified in the analyze phase. You're going to implement those, maybe not all of them, but you're going to implement some of those improvements, and then you're going to measure and validate that those improvements have any effect on my process output or not. So one of the concepts I want to talk about again in the improve phase, and to reiterate, is this concept of y is a function of x. And recall that what you did in the analyze phase is you identified all those different x's, the most critical x's or inputs, right? An x is also known as an input. So you identified those inputs that would have the greatest effect on the output that you want to fix, which is your problem, your the whatever it is you're trying to solve. And so what we want to now do is to brainstorm all the possible solutions that could help solve some of these root causes, help fix these critical X's. Because if you fix them, remember that's the hypothesis, is that is what's going to impact your process in a positive way. So the improve phase is all about forcing these changes to your process. You brainstorm what you want to do to fix these root causes. You implement those changes and measure the impact. And the reason we measure the impact is because we want to see which ones have greater impact versus others. Some will have no impact at all. And that's also good to know. So, it's one less thing that impacts your problem that you don't need to focus on. Okay. And then the final point I want to mention here is that for much more sophisticated problems, typically in a manufacturing environment, there is also a technique called a design experiment. And a DOE, or design of experiment, is a very powerful tool. We don't cover it in this course. If it's something that you think you need, then reach out to your coach in the portal and have a discussion. But it's typically an approach that is much more common in manufacturing and highly complicated problems. And it's really using statistics and detailed analytics to help you, basically figure out which factors impact a particular output and which ones might interact with each other to affect a problem. So it really is a very, very valuable tool, but it's rare that DOEs are needed, especially in a service industry, but typically lends itself for manufacturing and highly complicated problems. Okay, so I just thought I'd mention that. And if you do think you need that, by all means, reach out to your coach inside the portal. So as I mentioned, you're at the point now where you want to take all these top root causes that you identified from the analyze phase. Now, and sorry, when I say the top root causes, I don't mean all of the root causes that you brainstormed. I mean the subset, that critical list of factors that we said, hey, these are the most critical root causes. So I want you to take that list, and now you work as a team with all your subject matter experts to brainstorm all the possible solutions to each one of those root causes. So I want you to think of yourself at the point where you're in this kind of funnel. And what you want to throw into the funnel is you want to throw in all the ideas around how to solve one of those root causes, and you're going to go do it for each of those, and however many critical root causes you have. So you go really wide. Think of all the possible solutions that could impact and fix each of those root causes, and you're not going to implement all those solution ideas. You're going to narrow that list down to a couple of solutions that are going to fix each of those root causes, because clearly you just don't have the time. And it's going to be an exhaustive effort. You're not going to implement every single solution idea that people come up with. Okay, so you get your subject matter experts together. with the team and others to basically brainstorm these solutions to the root causes. And then basically you're going to have this list of prioritized solutions that you're going to implement to help fix your problem and measure that impact. Okay, so then what you're going to do is you're going to experiment and implement your solutions. So once you've got that shortened list of solutions, you're going to implement them, and that might require running some trial runs, maybe doing some, putting some forms in place to measure data, to capture information. You might have to do a little experiment, that sort of thing. But you're going to be doing things and gathering the data to say, hey, did we have a noticeable impact on our output, on our critical, output and our problem that we're trying to solve? Did we see a tangible improvement or not? Okay. And that is very important in just understanding which solutions work and which ones don't work. Now, when it comes to validating your improvements, what you want to do is, after you've implemented your actual solution, or maybe it's multiple solutions, right? You're going to want to measure that effect on your process Y, or your output. Okay. And you can do this in a variety of fashions, but this is really one of those areas where it really does help to sit down with your coach and to discuss, what you're trying to do, what you're trying to measure. They're going to help you understand exactly what's the best way to gather data before and after to see if you've made that improvement, right? Because you want to be able to compare your process performance after you've implemented a bunch of solutions with your baseline that you gathered way back in the measure phase. Okay, so to do that, you might be gathering data. You might have to plot it on a control chart. I think the control chart, to me, is one of the most important tools and techniques that I would use to plot my data on some of these improvements, because to me that's the most, and you can really do it on almost any process. And so I would highly recommend plotting your data on a control chart, and I'll show you some examples in a moment. But you can also use a regular run chart in Excel. You can use it on histograms, plot your data on histograms to see the difference before and after, or other graphical tools. Okay, and so there certainly are many different ways you can do this, and definitely reach out to your coach on what the best technique would be to measure the before and after for your process. Okay, so here's a couple of examples. This is an example of a control chart, and remember, a control chart on the top, the vertical axis, the y-axis here, is really the unit of measure, whatever that is. Maybe it's number of defects, maybe it's time, or not time, temperature or something like that you're measuring. And then of course along the x-axis is chronologically, so this is time, whether it's each data point you've gathered over time, but they're chronologically gathered. So in this case, keep in mind, this red line indicates the process average, or the mean, before. And then here's kind of, you've made your improvements, and here's the process mean after. So when you plot on the control chart, you'll see right away, is there a difference in my process averages before and after? Okay, because that's one of the critical things to look at, to say, did we make a change in our process? And one of those changes would be, hey, there's a meaningful change in the average of our data point, or the mean, or the center point, that sort of thing. And so this, clearly you can see that, wait, something happened in around this data point here where all of a sudden, whatever this measurement is, it was a lot less. Okay, so this is an example. A control chart will pull this right out of your data and show you right away. It's really, really quite valuable. The next kind of example on when you plot something on a control chart, another type of visualization that you might get is this one. So in this case, the red line still is your mean or your average, and you might not notice that there's any change at all to your mean or to your process average, but what's happened in some cases, you might notice a difference in variability. And so you can see that the amplitude, or the peaks and valleys of your process before, is highly variable compared to what it is now. And so in most cases, that's a good thing. Okay, and so certainly that's also an improvement. So you want to keep an eye out for these types of trends as well. And again, this is stuff that your coach can certainly help you with. So highly recommend plotting your data on control charts before and after in the improve phase, once you implement your solutions, to see, hey, did I make a meaningful impact on my baseline or not? Now, just before we conclude the improve phase, I thought I would cover a bonus topic. It's something that we don't go into a lot of detail in this particular course, because it is a little bit more of an advanced topic, because it requires some statistical analysis and whatnot. But when you get to the improve phase, it's one of the most common areas where in a Lean Six Sigma space, in a process improvement space, there might be some value in using a technique called a statistical technique called hypothesis testing. And it does require some statistics, which is why it's kind of left out of the Process Excellence Essentials course that you're enrolled in right now. However, I thought it'd be useful at least to mention it. And if it's something that you think is needed and or is valuable for you, it's something you should discuss with your coach as well. So what is it? Well, hypothesis testing is a way to validate with statistics the improvements you've made to your business process. Okay, so a hypothesis test really answers that important question: is there an appreciable difference or an appreciable and detectable difference in what you've done to your process versus where it was before? Okay, and so when we say difference, the difference is either going to be with your mean or my average of whatever that output is I'm measuring for my business process, or its dispersion, or what we call its variance and variation. So there could be at least one or two differences in terms of the average. Maybe I've moved it up or down, more in line with my specification, or I've made my process much less variable. Okay, both are potentially improvements you can see, and you can detect it using hypothesis testing. So the types of changes to detect are, typically fall into these four buckets. So if there's a difference in location, you'll see that these two kind of distributions are let's say this is my before data, the first, this first distribution or mountain here. And then if I've made a change, I've made an improvement to my process, I might have seen a difference in what we call location, difference in mean. Okay, and so there's tests that'll help us show that. If there's a difference in dispersion, which we talked a little bit, I showed you this in the control charts as well, then what happens is your variability changes, and you can see that one of your curves is much more narrower than the other ones. Okay, you might get a difference of both dispersion and location based on the improvements you made, and then it could look something like that. And then of course another absolutely inevitable outcome for some of your solutions are that there is no difference, right? And so how often have you been in a situation where someone says, hey, I fixed that process, I did these things. But if you go and you measure your process before and then you measure it after and you make these changes and you don't see a statistical difference, and you can kind of say, hey, listen, that factor plays no role at all in affecting this business problem. Okay, so you might get no statistical difference in location and dispersion as well. Okay, so if you want to get into hypothesis testing, you will need to figure out a reputable statistical package that'll help you do some of these things. Minitab, Statistica, SAS, JMP, and there are also some tools that are Excel add-ons. There's a tool that's not listed here called Process MA. That's an add-on to Excel. All of those platforms are really useful tools. And they will require license fees and that sort of thing. And now they will do this level of hypothesis testing if that's what you wish. Again, something that's worthwhile discussing with your coach because they've got experience in probably all of them. And then the most important thing is when you want to set out and do some hypothesis testing, we're going to talk a lot about sampling, because it's very important that you have the right amount of sample size. Otherwise, you're not going to be able to see any differences even if they do exist, right? So sample size is a very critical component of hypothesis testing. Okay, and the final thing I want to show you before we just basically conclude the improve phase. This is a very, looks a little complicated tree diagram here, but basically when you get into the world of hypothesis testing, recall that I think it was the measure phase, we talked about types of data. So at the very top here are those two most common types of data. There is continuous data, which is anything that's measurable, right? Maybe it's time, temperature, viscosity, something that I can actually measure in a certain increment. And then there's something called discrete data, if you recall, is basically yes, no type of data. Could be ordinal data, first, second, third, fourth, that sort of thing, where you can't actually measure it, right? It's either a yes or a no, or it's a good or a bad, or something like that. Okay, and you can see right away that if it's continuous data, your business process, and you're trying to measure your before and after using continuous data, there is a whole world of hypothesis testing that's at your disposal, and makes it really easy and valuable to validate when you've got differences or where you've got root causes that are actually true root causes. In the discrete side, you can certainly still deal with discrete data and determine using hypothesis testing statistical significance, but it's a much lower amount of tests and a much more limited number of tests, but still can be done. Okay, so I just wanted to put that out there. That is, the bonus material around hypothesis testing. Again, we don't really get into it in this course, but if it's something you need, reach out to your coach. And that should conclude the improve phase.